So one thing we talked about, area between curves is top minus bottom, right? And we know if we get it flipped, we'll have a negative. But you have to be careful. If you have two curves that maybe meet multiple times, and you just do the top minus the bottom, this one would turn out, like if you did it just this curve minus that one, this part would be positive and that would turn out to be negative and they would cancel each other. And that's not really the case, right? If I just want the area between them. So it's like the absolute value. You have to take each section and calculate those and add them together. So, let's do one. I want the area of the region bounded by the curves. Y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2.
I forgot what they were.
What?
Oh,
So
sine, isn't it on a
sine
pi?
starts at 0, 0,
Mm-hmm.
and cosine starts at 1.
Right.
Don't they go to pi as a full
2 pi is a full period.
2 pi?
Mm-hmm. But remember, sine starts at 0, and at pi over 2 it's 1, and pi it's back to 0, and so forth. Now I'm only concerned from 0 to pi over 2, so I need this section. And cosine, like Grayson said, starts at 1, and the cosine of pi over 2 is 0. So can we tell that they are going to meet there?
Yeah.
Now obviously my graph is not drawn to scale, so we can't just look at my graph.
Just do that.
So I need to know what that point is. So when does sine x equal to cosine x? Think about your hand trick. When are sine and cosine the same?
Probably.
Over 4.
Mm-hmm. Pi over 4.
Yeah. I was right there. I had the finger.
Okay, so from 0 to pi over 4, which one's on top?
That would
Sine.
be the sun. No,
Or no,
cosine.
So it'd be cosine minus sine. And then we'll have to go from pi over 4 to pi over 2, which one's on top?
Sine. This is a lot easier than the other absolute values.
Well, good. So what's the antiderivative of cosine?
Sine.
Minus, what's the antiderivative of sine?
Plus cosine x.
Mm-hmm. Here, antiderivative of sine
Negative cosine x.
minus the antiderivative of cosine.
Negative sine x.
So then we evaluate. So sine of pi over 4, so like sine of 45 degrees is radical 2 over 2. Cosine of 45, radical 2 over 2. Sine of 0 is 0. Cosine of 0 is 1. Okay, at pi over 2, cosine of pi over 2 is 0 minus the sine of pi over 2. 1. Have it in pi over 4. And then radical 2 over 2 minus radical 2 over 2. Okay, so when I add these, I just get the square root of 2 minus 1 minus 1 minus a negative, so plus the square root of 2. So 2 radical 2 minus 2. So you have to watch. If they meet multiple times, you have to see if they're switching which one's on top and adjust that. Is this okay? Alright, so then let's talk about those couple problems that I told you not to do yet.
Whoa.
So let's say I give you this. Find the area enclosed by the line, y equals x minus 1, and the parabola y squared equals 2x plus 6. So here's the issue. Normally we solve for y, right? So our equations are both y equals, and then when we set up our integral, we don't have the y's. But if I'm going to solve for y, I would have to square root, and I would have a plus and a minus here. So then what happens is I really have two equations over here, and then I'm trying to integrate a square root, and that's not friendly. So sometimes it's easier to use y as the variable. Now if you're doing that, that means you have to be able to get both of these in terms of y. So this one, if I want to solve for y, or get it in terms of y, that means get x by itself. X is equal to y plus 1. Over here, subtract my 6, divide by 2, so I'd have 1/2 y squared minus 3 equals x. So those aren't hard to solve for x. Then everything has to be in terms of y. That means when I set up my integral, my limits have to be y values. So I need to find when these things meet. So I need to know, when does y plus 1 equal 1/2 y squared minus 3? So if I bring everything over, if you don't want to deal with fraction, you can multiply by 2. What multiplies to -8 and adds to -2?
-4 and +2.
So y is -4, or sorry, +4 and -2. In terms of a graph, if you want to know what's going on here, the first one was just a line, y-intercept of -1, slope of 1. When you have y squared, that's a parabola flipped on its side. And so it kind of looks like this. So that's the area we're finding. And so you can see it's not really in terms of x, it's hard to find the left and the right on here, but the top and bottom aren't too hard. So when we integrate, we're going to do it all in terms of y. So starting at -2, ending at 4. All right, when x is our variable, we do the top curve minus the bottom curve.
So what would be the y squared?
You do the right minus the left.
Oh.
So the one on the right is our line. So that's what comes first. So that's y plus 1. Minus the left is this parabola. And this is dy in terms of y. So it's a little bit different there. What questions do you guys have? If you're not sure it's the right minus the left, if that confuses you, we can figure it out the same way we did the others. Pick a number in between 4 and -2, so maybe a 0. If I put a y of 0 in here, you get 1. Here is -3, so it's a bigger minus a smaller when you do that. So I'm integrating from -2 to 4. If I distribute this negative, then I would have a -1/2 y squared, a positive y, and a plus 4. Alright, so the antiderivative of -1/2 y squared. So add 1 to the power, 1/3 in front, so -1/6 y cubed, plus 1/2 y squared, plus 4y. So if I put in my 4, 64 over 6, 16 times 8. 18. So sometimes it's really complicated solving for x. We can keep our variable as y, but that means everything has to be y's. We have to be integrating y's, it has to be a dy, our limits have to be y values. How would you know if you flipped the first and the last? You would get a negative 18. So if you did that, you wouldn't have to redo the whole problem, you would just do the absolute value of that answer and say, oh, I flipped these, it really should be the absolute value, the answer is positive 18. Let's try one more of these. Find the area of the region bounded by the line y equals 1/2 x and y squared equals 8 minus x. Do you think it's easier to solve for x or for y? X. So this one, first one would turn into 2y equals x. The second one,
Negative y squared plus 8.
so let's say 8 minus y squared. Picture is optional. 1/2 x is just a line. This is probably less familiar for you what it looks like, but you can always plug in some points. If your y is 0, you're going to get 8. If your y, so we would have, when y is 0, we get out 8. If your y is 1, you get out 7. If y is negative 1, you get out 7.
Okay, so the translations are like flipped.
So when we set this up, we have to have the intersection point. So we need to know, when does 2y equal 8 minus y squared? So if I bring this over, y squared plus 2y minus 8. 5 plus 4, y minus 2. So we get negative 4 and 2. If you're not sure, so if you have the picture, it's right minus left. So my right one is my 8 minus y squared. My left one is the 2y. If you're not sure, take a number between negative 2 and 4. Or sorry, between negative 4 and 2, so maybe it's 0. And you're plugging that in for your y. If I put a y in, a 0 in for my y up here, I get my x to be 0. If I put it in here, I get my x to be 8. Which one's bigger? 8. So that's why this equation is first. So, antiderivative of 8 is 8y minus 1/3 y cubed minus y squared from negative 4 to 2.
Is it 36? Oh, no, no.
Yeah, I think it is 36. Yep. So, we have a lot of time to work on this. Tomorrow, especially for those of you that are gone, we will have class time, but I'm also going to give a handout with some substitution problems, because I think we still need a little more practice with those. So tomorrow is a work day for whatever you don't have done on this, and a handout that